Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. Now, I know you all had your heart set on a detailed explanation of radiometric dating today, but last night I had something that came up, and I thought that I would go ahead and switch gears a little bit right now. Last night we had the Beaver Moon eclipse. It was the longest eclipse in 548 years. Now, the reason that I didn't announce it was that, as you know, I've had some computer problems, and I didn't know what the weather was going to be like. Now, while most of the evening was completely socked in, at about 1 o'clock in the morning, the weather cleared up a little bit. So I got my equipment set up and I started to film the lunar eclipse. I was able to get started during the full moon. However, just as the moon hit the Earth's umbra, the entire internet in my town went out. I had connection with my routers, but I just wasn't talking to the internet, and as a result of that, I couldn't even communicate with a telescope outside. However, this matter resolved in about an hour, and between 3 and 4 a.m. I was able to capture the partial lunar eclipse. So I thought I would go over it real quick today. So let's cue up the music and get going. Well, let's take a moment and just have a quick look at what an eclipse actually represents. It has to do with the interplay of the sun, the moon, and the earth. Let me get out of here and we'll go over them. Now, on a solar eclipse, the moon is positioned between the sun and the earth. And as a result of the interplay of light on the shadow of the moon, we have a small area on the surface of the earth that experiences the sun literally blocked out by the moon. The angular size of the moon is about 31 arc minutes, and that's about the same as the sun. And as a result, all we see is the rim of the sun around the moon. The result is that the solar eclipse has a very narrow path, generally about 60 miles wide and between 60 and 160 miles long, that it follows over the surface of the earth. So, for example, the solar eclipse that will occur in approximately 2 weeks will only be visible over the Antarctic Peninsula and in the South Atlantic. Unlike the solar eclipse, the lunar eclipse is visible anywhere in the nighttime Earth facing the eclipse. That's because the shadow of the Earth is about 2.6 times the diameter of the moon. The solar eclipse is caused by the shadow of the moon being cast upon the Earth. The lunar eclipse is caused by the shadow of the Earth cast upon the moon. Now, Venus, the Earth, Mars, and the other planets orbit around the sun in a single plane called the ecliptic. And as a result of this, the shadow of the Earth is always cast out onto the ecliptic plane. Now, while the moon passes between the sun and the Earth once a month, and the Earth passes between the moon and the sun once a month, they're not always going to result in an eclipse. And the reason for that is that the moon's orbit is approximately 5 degrees offset from the ecliptic plane. And you can see that in this illustration. So here is the ecliptic plane right here, right above my head. And that is the center of the Earth's shadow on the ecliptic plane. There are 2 parts to the Earth's shadow. One is called the umbra, and the other is called the penumbra. In order for a full lunar eclipse to occur, the moon must completely pass through the umbra of the Earth's shadow. If only part of it comes through the umbra, we get a partial lunar eclipse, and if it goes through the penumbra, we get a penumbral eclipse. If the moon is in a point in its orbit that it passes above or below the umbra, there's no lunar eclipse at all. Lunar eclipses can only occur on the night of a full moon. Now, the eclipse that occurred last night was a partial lunar eclipse, which meant only part of the moon passed through the umbra of the Earth. However, it was a 97% partial eclipse, so only a tiny sliver of the moon remained visible in the penumbra at the height of the eclipse. Now let's go through the sequence of our eclipse last night. It started off as a full moon. This was probably around 12:30 or 1 o'clock in the morning. So let's go over this real quick. Now as you can see, here is the full moon. It has not yet reached the Earth's penumbra, so we see the entire moon. Now just to kind of give you some landmarks, this is the north pole of the moon. This is the south pole of the moon. That is the crater Grimaldi, marking the west limb of the moon. And here is the Sea of Crisis, marking the east limb of the moon. That's the Sea of Tranquility. That's the Sea of Serenity. This is the Sea of Showers and the Ocean of Storms. Now, as we progress through the eclipse, we reach a point, and that's when the moon first touches the penumbra of the Earth. Then, as time goes on, the moon begins to come into the Earth's penumbra. And you'll see that this side of the moon is much darker than this side, although they're both clearly visible. As time goes on, the moon passes entirely within the penumbra of the Earth and then begins to touch the umbra. And you'll notice that as the Earth comes into the umbra, it goes into darkness. There is a band right here as the transition is being made from the penumbra to the umbra. Now let's see what happened last night. Now let's identify a couple of things here. Now this insert is from Time and Date, and it gives you a live demonstration of what's going on in the night sky. Now at the bottom of this chart is a small timeline, and that is the phases of the eclipse. So for example, here is where the moon first touches the Earth's penumbra. The next point is where the moon touches the Earth's umbra. During this period of time, it's fully within the umbra. Here the moon touches the outside of the umbra on the other side. And in the final one, it clears the penumbra on the far side of the moon. Now, as you can see from the sequence, the eclipse started at the northwest limb of the moon. This is the northwest limb of the moon on my image. The north pole of the moon is over here, and the south pole is opposite here. My camera is tilted a little over 90 degrees to the image that you're seeing in the insert. Now in this slightly earlier image, you can clearly see the Sea of Crisis right here. That's located right here. Now as we move along, once again you can see the Sea of Crisis. Notice the crescent shape of the Earth's shadow, again confirming that the Earth is a globe, and see how well it corresponds to the graphic from Time and Date. Both the live image and the graphic were running concurrently as I was recording this video last night. And by the way, this was recorded between 3 and 4 a.m. my time, which is why we didn't have a video out Friday morning. Now at approximately 3:30 in the morning, the eclipse is getting near its maximum point. This is a very good image of the eclipse and a couple of things that you can see. First of all, there's only a small sliver of the moon remaining visible. Second, if you look very carefully, you can just barely see the outline of the moon in the shadow of the Earth. Again, notice the nice curved shape of that shadow reflecting the globe Earth. Once again, here's the live image of the moon compared to the graphic from Date and Time. You'll see that correspond very closely. And you can also see the orientation of the moon. If you look at the top of that crescent in the live image, you can see the rim of the moon in the Earth's shadow. We'll see this a little bit better in a moment. Now here we're approaching the peak of the eclipse. You can very clearly see the body of the moon in the shadow of the Earth. The reason that you can start to see it a little better now is that the brightness of the sliver of the moon is sufficiently decreased because it's so small that you're starting to pick up the Earth shine on the surface of the moon. This is just reflected light from Earth illuminating the surface of the moon that's currently covered in the Earth's shadow. We'll increase the gain here in a moment and you'll see this a little better. It's a beautiful rust red color. I've brought up the light a little bit here so that you can see it a little better, but you can clearly see it's almost got the same color as Mars. And here we are at the maximum point of the eclipse. It's about 4 o'clock in the morning, and we're getting ready to shut all this down. This is the point that we're seeing right now, which is the height of the eclipse. This is a 97% eclipse. Between this time, about 4 a.m. and about 7:30 a.m., the moon continued to move out of the shadow of the Earth, first the umbra, and then clearing the penumbra. Now, judging from what I've seen on the internet, I was very fortunate to have been able to catch this last night. We had very bad weather the first part of the evening. It was 100% overcast. It cleared about 1 o'clock in the morning. After I had my little issue with the internet, I was able to get about an hour of good images at the height of the eclipse. So, this is Bob the Science Guy signing out from Northern Michigan. I promise that we'll do radiometric dating next week. Take care, guys. Hey, hit that like and subscribe. And if you want to join the channel as a member or become a Patreon, it would certainly be appreciated. We've got a lot of things coming up in 2022.
Mama, please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting real sore.